If you look up at the night sky, you'll notice something. Thousands of tiny and beautiful dots of light. These stars vary in size, but they all share a common quality. They all appear circular. At least from our limited perspective, they seem perfectly round. Why? It might seem like an obvious or silly question, but is it really? Is it just a coincidence? Or is there something deeper at play in the universe? Why aren't stars cuboids or tetrahedrons? In his famous dialogue, Timaeus, the philosopher Plato argues that in a universe made of chaos and complex geometries, the sphere is the only shape that represents the essence of perfection, having a form that unites all directions, symmetrical and without beginning or end. So, according to Plato, planets would be circular because they represent the perfection of the cosmos and nature. But if this philosophical explanation doesn't convince you, here's a more scientific one. The answer lies in a fundamental force of nature: gravity. Gravity is one of the four fundamental forces of physics, and it is the force that attracts all matter towards a common center. The sphere is the shape that gravity chooses for itself. But why, among all possible shapes, is it a sphere? The answer lies in the pursuit of balance and the minimization of gravitational potential energy. Every particle of matter within a planet is attracted toward the center, and if the matter were not evenly distributed, there would be forces of tension and compression that would increase the gravitational potential energy. The spherical shape is the one that minimizes these forces, creating a uniform distribution of matter and thus making the celestial body stable. A cubic planet, for example, with points on the edges farther from the center of mass, would be inherently unstable. So, can non-spherical planets exist? Actually, no planet, including Earth itself, is perfectly spherical. While planets tend to have a spherical shape due to gravity, their perfect shape is not exactly that of a sphere. Earth, for example, is not a perfect sphere, but an oblate spheroid. This distortion in the Earth's shape is due to the centrifugal force generated by the planet's rotation. As the Earth rotates on its axis, centrifugal force acts outward along the equator. This effect is a result of the rotation, which pushes matter away from the axis of rotation and toward the equator. As a result, the equator is wider than the poles, creating an equatorial bulge and a flattening at the poles. Planets like Jupiter and Saturn exhibit even more pronounced oblateness compared to Earth. This is due to their extremely fast rotation. Jupiter, for example, has a rotation period of about 10 hours, and this rapid rotation generates a much stronger centrifugal force, causing significant equatorial widening. This effect is particularly evident in the gas giant planets, where the more fluid atmosphere easily adapts to these rotational distortions. An interesting example: the star Vega. It is one of the brightest stars in our sky, and a perfect example of how rapid rotation can affect the shape of a celestial body. Vega rotates so quickly that it is significantly flattened at the poles, to the point that its equator is much wider than the poles. It's not a planet, but it illustrates the concept well. Then there are bodies that aren't even spheroids, such as asteroids and comets. These celestial bodies are much smaller than planets and stars, and consequently have insufficient gravity to shape themselves into a spherical form. The gravity of an asteroid or a comet is too weak to overcome the internal cohesion forces holding their material together. As a result, these bodies tend to have irregular and often bizarre shapes. For example, they can be potato-shaped, like Ultima Thule, or onion-shaped, like Asteroid 68 Leto. Don't forget to like the video if you enjoyed it and subscribe to the channel to stay updated on future content. Thanks for watching, and see you in the next exploration of the universe.